Yeah, very good evening everyone. So my name is Chevuri Pavan Kalyan and I am from Arjuketi Ongol, Andhra Pradesh. Today I want to explain about my project IoT Based Home Automation Solution, which is an internship project from MX Information Technologies. So coming to the contents, yeah, starting with the C programming and introduction to IoT and embedded systems, introduction to home automation, project definition, block diagram of project components, coding, simulation and output, and conclusion. Coming to the thing, yeah, firstly starting about C programming language. In C programming language, I have learnt about data type modifiers and qualifiers and conditional statements and loops. Coming to the data type modifiers and qualifiers, something like integer, float, double, character, long, short, etc. And conditional statements and looping statements like if else, and etc. And also the operators such as while, do while, for, and also architecture, arithmetic, logical, and bitwise operators, arrays and pointers, functions, strings, storage classes. All these I have been learning in the C programming language, and I have learnt about the introduction to the C++ beyond the C, and so I have learned some of the syntaxes in the C++ language, and finally the introduction to object-oriented programming. So coming to our main heart of the project, Internet of Things. The term IoT refers to the things that are connected to the internet. IoT is simply the network of interconnected things or devices which are embedded with sensors, software, network connectivity, and electronic devices that enables them to collect and exchange data, making them responsive. Yeah, coming to the next slide is about the embedded systems. So embedded system, we all know that it is a the embedded the firmware into hardware to do one specific or a few highly focused jobs within real-time constraints. Embedded system is a combination of hardware plus software which are intended to do a specific task. Coming to the introduction to home automation. What is a home automation? Home automation means controlling, monitoring the home attributes such as garden lights, heaters, coolers, etc. by connecting them to internet and operating or monitoring them with mobile without any physical interaction with devices, without any human interaction. So an automated home is also known as simply called as a smart home. Next is the project definition. Yes, the main aim of the project is to access and control the home appliances such as garden light, cereal tank, etc. through internet. This home automation project is simulated on the PixSimLab simulator and the Blink IoT mobile application used to control the devices and Arduino IDE to write the code. Coming to the next slide is the block diagram. Yeah, block diagram of a garden light control. Here we can clearly see the connection between the Arduino UNO LDR sensor and lights. LDR sensor is connected to the Arduino UNO, which observes the intensity of the light and gives it to the Arduino UNO, gives the instructions, and then it will be connected to the lights, and the lights will be blowing. And coming to the temperature control system, we are having the temperature system over here. Three So we can clearly see in the block diagram such as a temperature is noted, and it is being the instruction is going into the Arduino UNO, and also the heater control and cooler control is given connected to the temperature system through the Arduino UNO and the LCD, and the notifications will be shown in the LCD, and also the temperature will be shown in the LCD. Here we can also see the Blink IoT application in the left side of the Arduino UNO board, where we will be able to access the temperature and give the information regarding the heater control, cooler control, and the notifications, etc. in the Blink IoT app. So yeah, this is the block diagram. As I already mentioned, it is a block diagram related to the water tank inlet and outlet valve control. Here also we can clearly see the water tank and the LCD and the Blink IoT app connected to the Arduino UNO board, where the volume of the water will be measured, and it will be given to the Arduino UNO board the instructions, and also that will be shown in the LCD. All the notifications will be shown in the LCD, and the volume of the water is also shown. So volume of the water, inlet valve control, outlet valve control, all these will be connected to the Blink IoT application, and also here we can see the water tank and Arduino UNO are connected with the inlet valve control and outlet valve control. We can see here, yeah, I forgot to say something. If the water inlet is greater than 200, less than 200, uh, and less than 2000 liters, then it will be intimated as the inlet valve. Uh, Inlet will be on, and when it is greater than or equal to 3000 liters, the inlet valve will be off. Yeah, that's the main thing what we are doing over here. Yeah, this is all about water tank inlet and outlet. Coming to the next one, yeah, coming to the basic things such as tools what we have used. The main thing we have used is the Arduino IDE, which is the open source Arduino software, which makes it easy to write code and upload it to the board. And what the language we used is the C++. And the next main thing we had used is the PiximLab. PiximLab is a real-time emulator of development boards with an integrated debugger. Here we connect all the required spare parts and we load the compiled hex file. Next tool what we have used is that yeah, Blink IoT application. It is a platform for iOS and Android smartphones that is used to control Arduino, Raspberry Pi, Node MCU through internet. Using this we can control hardware remotely wherever we are. Coming to the next one is the null emulator. Yeah, talking about null emulator, it is used in this project to establish a serial communication between Arduino IDE and PiximLab. uh, Coming to the major hardware components what we have used are the LDR sensor, LED, CLCD, and the temperature sensor like LM35, heater and cooler, Ethernet shield, and Arduino UNO board. All these are the components, hardware components we have used in this. Yeah, coming to the main component, main heart of our project is the Arduino UNO board, where it is an Atmega 328P based microcontroller board which has 14 digital I/O pins, of which 6 can be used as a PWM pulse width modulation outputs and 6 analog inputs. And there will be a 16 megahertz crystal oscillator and a 12C and SPI communication interface also is there in this Arduino UNO. Yeah, next talking about the uh, Blink console configuration. To connect the devices to the internet, we have to create a template here, and we have to create a device for the template, and we have to divide virtual pins. All will be done in this Blink console configuration. For this project, my device is a home automation device, and I created a device for using this template. Yeah, coming to the next thing is the Blink app configuration. After completion of the Blink configuration, we are creating Blink app configuration in Blink IoT. mm, we'll be using two tabs, one tab for temperature control system and another tab for is for the water, water tank, water control system. We are creating the buttons using this in this Blink IoT application. We are using the terminals even. Yeah, will be getting the notifications over here. Yeah, this is the coding. Coming to the coding, yeah, this is the coding what we have done. uh, yeah, these are the screenshots of our earlier outputs. So coming to our output, and yeah, it's time to give the demo of my project. Let me opening the Arduino UNO and PiximLab. This is Arduino IDE. I wrote the codes. All these codes have been written for all these things. Let me compile me first. As I said earlier, let me compile it with binary format, which is a microcontroller understandable language. Yeah, compiling is done. Let's open the PiximLab. This is an Arduino UNO board, and this board will, if you go to tools, modules, yeah, we'll go, you seeing the spare parts over here. Yeah, here we can see the LCD which uses I2C protocol, and this is a temperature control system which have heater, cooler, and temperature sensor, etc. This is an Ethernet shield we have been using. This is the LDR sensor, and these are the LEDs. One more thing is serial tank. Let me connect the serial tank. Yeah, it is connected to COM1. It is communicated with the serial communication. Yeah, that's the reason why I connected to the COM1. I am done with my connections now. So coming to the file, loading the hex file, the Arduino IDE. Yeah, compiling is done. I loaded the hex file. Yeah, here we can see the input. Yeah, this is my mobile screen. The shown is my mobile screen where I am connecting it through the USB connection. Firstly, let's look into the working of garden system, which is based on light intensity of the yeah. If you see here, this is the LDR sensor, and the above are the LEDs. The light intensity, it is less here. If you increase the resistance, if the light intensity is more, there is no need to turn on the LED. So LED is turned out. If you increase the resistance, automatically the brightness of the LEDs are going to increase, which is like that. Light intensity is going to increase, and it is going to decrease if we decrease that, like that. So this is the light intensity thing. Yeah, let us control the temperature system now. Yeah, this is my mobile screen, opening the Blink IoT. It's taking time. Yeah, it's about to open. What happened? Yeah. Okay, now it's open. Blink IoT app configuration. There are two tabs, tab 1 and tab 2, as I already said. Tab 1 for temperature control, and tab to control the heater, cooler, and to know the exact current temperature, and to get the notifications in the notification tab. And the tab 2 is for control inlet wall, outlet wall, and to know the exact volume of the water, current volume of the water. Let me start with this. Yeah, current 27 temperature is 27.37. I am going to turn on the heater. Temperature is turned on. We can see the change over here. We can see the change in Blink IoT also. When the temperature is above 35, if it is above 35, it is turning off. That's the automatic thing what we done here. If you turn on the cooler now, if you turn on the cooler, the temperature will automatically decrease. We can see the fan rotating and the temperature is decreasing over here. You can see the current temperature in the LCD as it is shown. Yeah, heater turn on. Yes, we can see it once again. It is increasing. Like that, when we are turning on these things, we'll also be notified in the Blink IoT application. This is about temperature control system. Yeah, coming to the water tank, serial tank 2, tap 2. Serial tank is initially having 0, but it is 0 if it is less than 2000 liters. At the time, we need to directly on the inlet valve. That's our perspective. That's why the tank is completely filled. If you turn on the outlet valve here, the volume of the tank will be decreasing. Yeah, we'll be able to see over here, the volume is decreasing, even in the Blink IoT app and also in the LCD. So we program like that. If the volume is less than 2000, automatically it should outlet should be on. And if we see the inlet valve open, the capacity of the tank is 3000 liters. If the capacity is 3000 liters, it will automatically outlet will be on. That the tank is going to fill in few seconds. If you see now, yeah, we see it reached the maximum limit 3000 liters. So directly automatically it was off, and even if we can see the notification over here, you can see the notification water inflow disabled. Yeah, this is all about my demo regarding the home automation. Yeah, coming to my conclusion point of my demo project is that with this project we'll be able to handle some of the home appliances through Blink IoT application, to send and receive the notification through Blink IoT cloud, and it gave a lot of some efficient knowledge and fruitful knowledge regarding the home automation system. Yeah, thank you so much for giving this opportunity.